Welcome to this session about how you can partner with Danfoss Cooling, getting access to our unique expertise, testing environments and technology. Today there is an increasing demand for new solutions, and this is due to higher efficiency requirements, use of low GWP refrigerants and requirements for lower carbon footprint. This is making the HVACR system much more complex and technologically advanced. So how can we help you to solve this? We are making significant investments in R&D and developing the widest portfolio of solutions for our industry. We send alongside you our dedicated application experts that has a system approach and also the ability for complex problem solving. We are continuously investing in state-of-the-art testing facility. We're also developing software and simulation tools that can help you to shorten your time to market. So with this unique blend of competences, application knowledge, simulation services, and laboratory testing, and above all, our customer-centric, dedicated people, we are the right partner for you. Now I would like to bring the word over to Damien, my colleague in France, who will walk you through how to partner with us for system simulation.
Thank you, Alice. Hi, I'm Damien Casetta, and I'm an R&D manager in Danfoss Cooling. I'm super excited to give you an update on our virtual capabilities that provide good advantages for customers. We've developed new engineering services based on simulation technologies. These provide two types of advantages. First, this saves cost, and second, it reduces time to market in your new development project. But what do we have behind the scene? Well, we have a software that is well established in our industry that we complemented by, let's call them plugins, that enable to simulate Danfoss products in the global system. We have a dedicated team that masters this software and is connected to relevant product lines. So we get the product expertise to set up the system in the software. We get support from the application team to, in the end, deliver you engineering services that helps you design your new products. Well, we have this multi-component approach, as we call it, because in the end, we have to optimize systems. We have to increase capacity, increase system efficiency, or reduce charge. So we can play on all of those parameters. We can play with all components like scroll compressors, including variable speed, or microplate heat exchangers and microchannel heat exchangers. But last but not least, we can also change refrigerant in this software. Well, you can then evaluate what could be the impact of going from your current refrigerant to a lower GWP refrigerant, analyzing the global impact on performance, but also like zooming in on each component and analyze how conditions are changing with this new refrigerant. But now stop the theory. Let's go to the examples. And I will tell you the story of a customer case that we ran recently, and it was all about helping a European heat pump manufacturer in its transition to lower GWP refrigerant. In the scope, it was about compressors and heat exchangers. And actually, it was all about going faster because it had to launch its product within a year. So A3S value, the simulation service value, was to provide this speed to help him going faster and making its own technical evaluation faster. Basically, its current design was with R14A refrigerant, and it was featuring breastplate heat exchanger with this standard fishbone plate design. It was a brine-to-water heat pump, and the final aim of this collaboration was to evaluate what would be the Danfoss solution performance with a new refrigerant here, R454B. Well, at first, we selected compressors. We've simulated compressor combination with fixed speed, variable speed tandems. We simulated heating capacity, and then we compared with the heating capacity requirement. We repeated for each capacity, each size in the customer range. So we've been able to deliver recommendation for a full compressor design base. Then came the second requirement in terms of full load system efficiency. And here we selected heat exchangers, so both evaporator and condenser with microplate heat exchangers, but with this trade-off between efficiency and cost. On this task, we could benefit from the low brand-side pressure drop delivered by the dimple plate design technology. Okay, so we have compressors, evaporator, and condensers selected, sized. So basically, we have our system design. At this stage, it was about running the full system in simulation and checking running conditions of each component to see if they were within their operational limits, like if the compressor was within its operating map. Okay, we did that for standard conditions, like in the European heat pump standard, and for extreme, let's say, limiting conditions as prescribed by the customer. The last task was to go part load. Part load is super important for seasonal efficiency requirements in like this so-called SCOP. So we optimized capacity control, how many compressors are on, what is the frequency of the variable speed controller, to optimize the full system efficiency out of a given design. So in conclusion, we proposed to the customer two system designs, one with only fixed speed compressors and the other one with one variable speed compressors. It had all the data at hand to select which one will be its next product. We could prove by simulation from 6 to 10% efficiency gains while changing refrigerant, while going to a refrigerant with lower impact on climate change. We could help him go faster, speed up its evaluation, and now we are at the stage where the customer is building a prototype and then testing. On this stage, our application team is still supporting, but okay, now it's about test. So let's hear what Lars will say about our own testing capability at Danfoss.
Thank you. What I would like to show you here is something about our testing capabilities. The system that Damien has told you about and done simulation on, we are able to do tests on that in the lab here. For testing commercial heat pumps with brine and water, we have a test system like this. We are able to perform tests according to EN standards. The standards are EN 14511 and EN 14825. On the left side here, we have the connections to the heat pump. We have water connections and brine connections that is connected through the hoses to the heat pump. The system contains heat recovery, which gives it a rather big capacity. So we are able to run tests on heat pumps up to a capacity of 100 kilowatts. On the heat rejection side, we have a cooling water system connected. That means we are getting a wide range of temperatures that we can test. We are able to test from minus 15 to plus 20 on the brine side, and from plus 15 to plus 65 on the water side. We are also using this test system for other purposes. We are using it for internal projects also, so it's not just sales projects that we are running with these systems. The latest test that we have done with this was part of an innovation project where we had a master thesis student here, and he used this test system for making a bench line on a commercial heat pump. The purpose of this this project was to investigate how to get to the next level of energy efficiency, and he then used this baseline testing to make simulations of different system setups in order to see how much he could increase the energy efficiency using different setups. And his results was quite encouraging. He got results of increasing energy efficiency about 10% by changing the system setup.
Thank you, Damian and Lars, for the examples shown. I hope you found some inspiration in the brine to water heat pump task. As for the system simulation services, they cover the heat pump applications, but also the air conditioning applications, as well as refrigeration applications. As for our application development centers, we are able to cover a wide area of applications. As you can see, we are globally represented, and each of the application development center is adapted to the region's special application requirements. They also work closely together with the regional Danfoss sales team, as well as with the relevant Danfoss product development teams. When we go to west, to Tallahassee, Florida, USA, we found an application development center that is specifically equipped to test all kinds of air conditioning units. They can also test units, reversible units in heat pump mode. The test capacity range starts from 4 kilowatts for, like an example, a small residential split system, and up to 176 kilowatts for rooftop units. And it reaches its maximum of 528 kilowatts of testing capacity for air-cooled chillers. This application development center works specifically in close cooperation with the Danfoss development teams for compressors. Heading to Europe, to Nordborg in Denmark, where in the application development center where I am right now, we find a lab that can test various types of heat pumps. The test capacity for heat pumps is up to 25 kilowatts on the air side and up to 100 kilowatts on the water side. The lab can also test smaller air conditioning systems as well as various types of refrigeration systems. This application development center works closely together with the Danfoss product development teams for controls and expansion devices. If we go a little bit to the east, we come to Chennai in India. This lab is a recognized testing lab of Intertek in India, and therefore also holds an ISO 17025 accreditation. This application development center is also set up specially for test of air conditioning units. It can test various types like split systems, rooftops, VRF units, and also both air and water-cooled chillers. The test capacity ranged from 3 kilowatts and up to 200 kilowatts. It also has a special setup for testing of condensing units up to 40 kilowatts, and therefore also works closely together with the Danfoss development teams for condensing units. If we go further to the east, we come to our newest and largest application development center in Haiyan in China. This application development center can cover the widest range of applications, also in terms of capacity. It can test various types of heat pumps. It can test condensing units, commercial refrigeration systems, various types of air conditioning units, split systems, rooftops, and also both air and water-cooled chillers. The testing capacity here is unique. It can test from 3 kilowatts to 700 kilowatts on the air side, and from 140 kilowatts to 2,800 kilowatts on the water side. This application development center works closely together with the Danfoss development team for heat exchangers. When we look at the ADCs globally, they all can perform tests according to national and international standards. We often are possible to go beyond the standard requirements for, like example, on temperatures, so we also can support special customer requirements from you. An example is we can test in heat pump mode at an ambient down to minus 29 degrees C. We can also test an air conditioning system at an ambient up to plus 60 degrees C. All the testing labs are equipped also to test unit charge with both non-flammable and flammable refrigerants. On smaller applications, we also have the experience to support testing that includes exchange of refrigerants from a non-flammable to a flammable refrigerant. The application development centers has aligned processes across them globally. And by this we also secure transparency and efficiency in the support we give to you, our customers. Our main goal is to have a collaborative environment where we can offer testing for you, our customers, both on verifying new system solutions and help improve existing solutions. So the collaborative environment we bring to you is together with the Danfoss application experts, with the simulation experts, and with the professional testing labs. I hope you have found some inspiration in how you can also cooperate with Danfoss to bring value to you and your customers. If you want to know more about how you can partner with us, just contact your local sales representative.